Alright, this is a 3.4 extension video of factoring expressions. Make sure you're taking your notes as you go. We're going to start off with the key idea. The key idea here is factoring an expression. So in words, it would look like this. Writing a numerical expression or algebraic expression as a product of factors, and you can use a distributive property to factor expressions. Sorry about the little hiccup. I had to fix that, and that's the only way I could do it. You'll be fine. So what does this look like in numbers? So you would have 3 times 7 plus 3 times 2 would equal 3, and then you would put in parentheses the 7 plus 2. So basically what I did was I'm doing the distributive property backwards, and I'm ending up with what it would look like in the beginning. Example 1 is factoring a numerical expression. So the directions would read like this. Factor 20 minus 12 using GCF. If you need a review of GCF, you can go back to the Chapter 1 folder on Schoology, and I have a video in there that says GCF versus LCM. So at least you can see how to do the GCF in there. And that way you can have a good idea. That's doing it the prime factorization way, but you can do it either way. So you start off with 20 minus 12. And we want to find the factors of each. So we have the factors of 20, and we're going to have the factors of 12 that we need to find. Once you factor them out, then you say, which one is my greatest common factor? Well, my common factors are 1, 2, and 4. And my greatest common factor happens to be the 4. So because 4 is our GCF of 20 and 12, we're going to write each term of the expression as a product of the GCF and the remaining factor. Then we can use a distributive property to factor the expression. So it will look like this. We start with 20 minus 12, and that equals, we use our GCF, okay? Then you have to ask yourself, what times our GCF did we use to get 20? So 4 times what equals 20? 5. So that's what we fill in. We use the same operations, we use subtraction, and then we list our GCF again, and then we have to list what is the other number. 4 times what equals 12? It would be 3. So my 5 came from a factor of 20. My 3 came from a factor of 12. So now I can use it into the distributive property, and it would be posted like this as our answer. 4 times 5 minus 3. Because if you think about it, if I were to check it and distribute back out my 4 times 5 is 20, 4 times 3 is 12. Does this equal 20 minus 12? Yes, it does. So this would be my final answer. I'll just rewrite it over here. 4 times 5 minus 3. That's my final answer. All right, our second and final example is factoring an algebraic expression. So this one's very similar, but we're not using just numbers anymore. We're going to put into play some variables. So this one's very similar in what we just did before, but this time it says factor 5x minus 15 using GCF. This time we're going to use our prime factorization. So if we start off with 5x, and make sure you leave the x on there, and we have 15, 1 times 5x is going to get me, or actually I should do it like this, sorry. Instead of the 5x, I'm going to put my 1x times 5, okay? Because that will show you that that's as far as I can go. With 15, I have 3 times 5. And so if I were to list them, 5x would look like this. 1x times 5, and 15 would look like this. Because we're getting them down to their prime, right? So what is the common prime factor of both of them? It's 5, which makes it the GCF. So now, to write this one out, it's going to look a little bit different because that x is in there, but not much. So we have 5x minus 15 equals We have the 5 times what gets me 5x, the x, and that was coming from over here. You don't need to put 1x, you can just put x. Minus, I'm using subtraction because that's what we originally began with, was subtraction. And then I have 5, because that's our GCF. 5 times what equals 15? 3. So then when I rewrite this out as a distributive property, I have 5 with my parentheses x minus 3. And that would be my final answer. So 5x minus 15 equals 5 times x minus 3. Okay, so I'm going to have you try these, but before I put them on there so you don't have them right away, I want you to pay attention to what the directions say to do. Factor the expression using the GCF. So try these 6. Remember, trying to find the GCF. If you're not sure how to do it, look back into the example I just showed you. So rewind it a little bit. The next page will have the answers for you. If you're getting it incorrect, try to go back to your steps in your notes and see exactly what we did in example 1. And I'll just tell you, numbers 1, 2, and 3 are all from example 1. And then 4 and 5 are from example 2. And here are the answers, like I said. If you are getting them incorrect, please go back to your notes and see if you can figure out what you did wrong. When you come to class tomorrow, we will review so that you're not completely lost. This is not an easy concept to learn. It's just one of those that is good to understand. So make sure you're really trying hard to look back at your notes on that. See you tomorrow.